Hey there! In this video we are going to talk about a time management pattern applied to state machines and XState. It's called throttling. With throttling, you can ensure that a function is called the first time you execute it, but then disallow its execution for a certain amount of time, like 1 second. It's really useful to rate limit costly JavaScript calls or API requests. For instance, if you listen to window resize events, you may want to rate limit how much the callback is called, because if the user plays with the window, you will receive a lot of events. So rate limiting is important in these cases. Let's see how we can use XState for this. This is a little demo we will use to understand how we can use throttling with XState. Every time I click on the increment button, the counter is incremented. Instead of this, we want to increment at most 1 time per 500 milliseconds or 1 second, whatever you want. We want to rate limit this, and when I click for the first time, we will directly increment, but then we will create a timer of 500 milliseconds, and while this timer is pending, we won't be listening to the increment event. Let's see how we can do this with XState. This is a state machine for this demonstration. So we have a single state called idle, and in this state we listen to click and recent events. When we receive the increment counter events, we make an assignation to the context. We increment it by 1. To throttle, we need another state because we need to create timer, and while this timer is pending, we won't be listening to the click event anymore. So the first step is to create another state called throttling, and there, instead of being a self transition to idle state, we will target throttling. In this state, we use a delay transition of 500 milliseconds, and after this timer, we go back to the idle state. If we test this, if I try to spam the button, you can see that the incrementation is rate limited. I can't increment more than 500 milliseconds. If I go back to the code and try a bigger timer, like 2 seconds, let's see what happens. At most 1 time per 2 seconds. But what does happen if I just stop clicking? Like click 1 time and then nothing else. You can see that nothing happens special, it just does nothing. Contrary to the debouncing pattern you may have seen in another video, you can see it online on my YouTube channel, the throttling is to just discard events for a certain amount of time. Debouncing will push and push again when the operation is made. With throttling, the operation is made at first, like there. The first time we click, we increment the counter, and then we just stop listening for 2 minutes. This is how throttling works, and this is really basic with XState. The example with the increment button is not really realistic. A better real-world example is a useIdle function, composable from VueUse. VueUse is a collection of composables for Vue.js developers. It's a really great library, and it exposes a useIdle hook. This will track any events that the user does on the page, like moving the mouse or resizing the window or scrolling, things like this, and it will detect if the user is idle by waiting for these events to happen. If these events don't happen for a certain amount of time, You can configure it like 1 minute, 10 minutes, or 5 seconds for this demonstration. Then the user is considered idle. And it's using throttling, so we will see how we can re-implement this tiny part of the useIdle composable with XState. I won't go too much into the details of this machine because it might be the subject of another video specifically about creating a user activity state machine. But for you to understand how things work, let's see. So the objective is to listen to a bunch of events on the window global object, like mouse down, resize, key down, touch start, and wheel. And for this, I have a callback actor that listens to each of these events and sends an activity event to the state machine. So this is all you have to know about this, and we'll start to see how things work in the state machine. So first, we have an active state telling the user is not idle, she is active. And there is an inactive state, which is the opposite. The user, when idle, is inactive in the sense of the state machine. So the initial state is active. When in active mode, the state machine directly configures a timer of inactivity timeout. You may not have seen this way to write with XState before. This is a dynamic timer. You can use dynamic delays with XState. So this is the name of the delay, inactivity timeout, and you can access the context of the event from there. So in my case, I'm receiving the timeout from userland, and the user can configure what is a timeout to decide whether the user is active or not. So this is why I'm grabbing this from the context and not making it something static. So in active state, then we create a timer. But each time we receive the activity event, which is every time the user interacts in whatever way with the page, this state machine receives this activity event, and I go to the active state, I render it so that the timer is recreated. This is an important topic about timers, and we discuss it in the video about debouncing. Please check it. Render is very powerful when dealing with timers, with other things like invocations, but with timers it's very powerful because you don't have to clear and then set the timer again. It's done automatically for you with this transition to the state itself. So when we receive the activity events, we assign to the context when the user was last active. This is a timestamp like day.now. This is how the timestamp is generated. So the objective there is to rate limit how much this function is called, because when the user resizes the window a lot or scrolls, these events will be fired a lot by the browser, and we will be assigning the last active timestamp to the context a lot. And what's more important is that we would create and clear this timer a lot. So instead of this, we want to just stop listening to the activity event for, we will say, 50 milliseconds. This is what VueUse does with the useIdle callback. They have this throttling of 50 milliseconds. So the first step there is to make this a child state. We'll call it idle, as this is common with my developing practice with XState. The first state, which means we do nothing, I usually call it idle. So idle is the initial state. And now we want to create a throttling state, and there we will wait for 50 milliseconds and target idle back. So there, instead of targeting active and re-entering the state, we will target throttling. That way, instead of recreating this timer a lot, let's say even if we create a timer per 10 milliseconds, instead of this, which means instead of 5 timers of 10 milliseconds, we would create a single timer of 50 milliseconds, and that way we would prevent from creating more timers. This is an optimization. Maybe it's not really necessary. This is something I saw from the useIdle composable code, but I think it's interesting to implement it and to think about throttling is optimization. There we want to optimize, so how do we throttle there with state machines? And this is how we throttle. So if we go to the demo code, we shouldn't expect any modification in the behavior. This is a replication of the demo of useIdle composable, and you can see that after 5 seconds, I chose a timeout of 5 seconds for the demo, we became idle. If I move the cursor or resize the browser, we can see that idle is false and inactive remains 0. But after some time, doing nothing, we can see that the timer increases and idle becomes true. So we made it. We made the user activity state machine use throttling. This is an optimization, but it's interesting because sometimes you prefer to create a tiny timer instead of running JavaScript code in loops. Thanks a lot for watching this video. I hope you learned something about time management and throttling pattern with XState, and see you soon for the next video. Bye!